In this video, we're going to finish up section 5.2, talking about reciprocal and quotient identities. So the reciprocal identities, we already saw that cosecant is the reciprocal of sine. So we could, how we have defined the sine function is opposite over hypotenuse. So what that means is cosecant is the reciprocal of that hypotenuse over the opposite side. A second way that we can get to cosecant from sine is by using the fact that we already know cosecant and sine are reciprocals of each other. So cosecant is the reciprocal of sine, so that means cosecant is equal to 1 over sine theta. Similarly, sine is equal to 1 over cosecant theta. Now what this tells us, this kind of shortcut, is that if we have the cosecant function, if we have the value of that, we can just take the reciprocal of that to get the sine function. So using the same idea, we know that cosine is the reciprocal of the secant function. Similarly, secant is the reciprocal of the cosine function. And then lastly, it follows with cotangent and tangent. Next we have the quotient identities. Now the quotient identities are useful because they can relate sine, cosine, and tangent all together. So if we divide sine by cosine, well, the definition that we've come up with for sine is opposite over hypotenuse. That's all divided by cosine, which is adjacent over hypotenuse. Now, if we have that, we can go ahead and cancel this common denominator, and that leads us to just having opposite over adjacent, which is equal to tangent of theta. So what that tells us is sine theta over cosine theta is equal to tangent theta. So that is one of the one of the quotient identities. And what we saw back here was that if we know tangent, or rather, if we know cotangent, if we take the reciprocal of tangent, we can get to cotangent. So the reciprocal of tangent is 1 over tangent theta. That's just going to be the reciprocal, so cosine theta over sine theta, and that is equal to cotangent theta. So this is our second quotient identity. Now let's look at a couple of examples that will use the reciprocal and quotient identities. Here we have a question that says, in a right triangle, let sine theta equal 5 over 13 and cosine theta equal 12 over 13. Find the value of the 4 other trig functions. So what's helpful here to realize is that since sine theta is equal to 5 over 13, well, sine is the opposite over hypotenuse. So what that means is the opposite side of the angle theta is 5. The hypotenuse for this triangle is 13. So if we draw a right triangle here, and anytime we have one of these types of questions, it's probably a good idea to draw a triangle. So we'll have angle theta down there, and what this is saying is sine of theta, well, opposite over hypotenuse. So the opposite is over here, and the hypotenuse is 13. Similarly, cosine theta is adjacent over hypotenuse. So that tells us the adjacent side is 12, and the hypotenuse is 13. Well, we already have that. Now from here, we can go ahead and find the value of the other 4 functions. So what we have, we need to figure out tangent theta, cotangent, and then secant and cosecant. Now, we don't necessarily even need to use the triangle here, but the triangle is just going to confirm our solution. So we know that secant is the reciprocal of cosine. So the reciprocal of cosine is just 13 over 12. Secant is just the reciprocal, cosecant is just the reciprocal of sine, so that's going to be 13 over 5. To figure out tangent, we're going to do sine theta over cosine theta. Well, sine theta is 5 over 13 all over 12 over 13. 13's cancel, we get 5 over 12 there. Let's move cotangent down. So cotangent is just the reciprocal of tangent. So this is going to be 12 over 5. So we have 12 over 5 for cotangent, 5 over 12 for tangent, 13 over 12 for secant, 13 over 5 for cosecant. So using these reciprocal and quotient identities, kind of a shortcut from just using the triangle. In this example, we are asked to find the 5 other trig function values for theta, given that theta is an angle of a right triangle and sine theta is equal to 2/5. So we can put theta down here. I could have just as easily have put theta up here. Doesn't matter as long as it's one of the acute angles for the triangle. We'll keep theta in this position. Now what we know is that sine theta equals 2/5. Well, 2/5, because this is sine, we're saying opposite over hypotenuse. So the opposite of this angle is going to be 2 down here. The hypotenuse, oops. The hypotenuse is up here. Now what we need to do is we need to find the side y. So we would use the Pythagorean Theorem. We'll say 2 squared plus y squared is equal to 5 squared. 4 equals y, 4 plus y squared equals 25. Y squared equals 21, so y is equal to the square root of 21 here. Now that we have all 3 sides of the triangle, we can go forward with calculating each of the values, each of the trig function values. So cosine theta, well, cosine is adjacent, so root 21 is the adjacent side here, and the hypotenuse is 5. So adjacent over hypotenuse, root 21 over 5. Tangent theta, tangent is opposite over adjacent. So this will be 2 over square root 21, and we need to rationalize this. So multiply the top and bottom by root 21. We get 2 square root 21 over 21. Now getting to the 3 other functions, we have cosecant theta. Well, cosecant theta is just the reciprocal of sine. Now we know that sine is 2/5, so the reciprocal is going to be 5/2. Secant theta, secant is the reciprocal of cosine, so we could say take the reciprocal of cosine, which will be 5 over square root 21. Again, we need to rationalize, and we end up with 5 square root 21 over 21. And then lastly, we have cotangent theta. Cotangent is the reciprocal of tangent. Now, we could use this version of tangent or this version of tangent. We're going to use this first version because when we take the reciprocal, we don't have a radical in the denominator. So square root 21 over 2 is what we would want there. And then let's move along to 2 application questions. First, we have to determine the height of a cloud at night, a farmer shines a spotlight straight upward to a spot on the cloud. The angle of elevation to the same spot on the cloud from a point located 150 feet horizontally from the spotlight is 68.2 degrees. Find the height of the cloud. Now, when you have a question like this, we just want to realize that this is a right triangle that we have. So here's our right angle. And this angle, 68.2 degrees, let's call that angle theta. So from angle theta, this 150 feet is the adjacent side, and we're trying to figure out this height, and let's call the height the opposite side. So what we want to do is we want to set up an equation that uses one of the trig functions. So the trig function that uses the adjacent side and the opposite side, well, one of those is tangent. Tangent theta is equal to the opposite side over the adjacent side. Remember, SOHCAHTOA. So tangent here is the opposite side over the adjacent side. So what we're going to do is, for theta, we enter the value of the angle. So tangent of 68.2 degrees is equal to the opposite side. We don't know that. Let's call it h, divided by 150 feet. So we want to solve for h, so multiply both sides by 150. We get 150 tangent 68.2 degrees equals h. So we want to solve this for h, and we'll use a calculator to do so. So to figure out the value of h, to figure out this height, really all you need to do is enter this directly into the calculator, 150 tangent 68.2. Now there's two separate modes on your calculator, any scientific or graphing calculator. We can have degree mode or radian mode for the angle. Now what you need to do is look at the angle that we're inputting. This is an angle measured in degrees, so we really need to use degree mode on the calculator. If you are stuck in radian mode, you're going to get a different and incorrect answer. This is one of the most common places students make mistakes when using a calculator, is they're in the incorrect mode. And if you're unsure, just look at the angle. What's the angle measured in? Here we're measured in degrees, so we must be in degree mode. So typing this into the calculator, we're going to get 375, let's call it 0.03 feet, and that will be the correct answer. All right, and then the last example, a little blurry. It says a surveyor wants to measure the height of Mount Kilimanjaro by using the known height of a nearby mountain. The nearby mountain has an altitude of 8,720 feet. The distance between the location and Mount Kilimanjaro's peak is 4.9941 miles, and the angle of elevation from the lower location is 23.75 degrees. Use this information to find the approximate height of the mountain. So what we're going to do first is we're going to find the height right here. Okay, so we're going to use this triangle. Now what we know is that our angle theta is 23.75 degrees, and what we have from that angle is, well, we have the opposite side, and then we have the hypotenuse. So when we're talking about opposite over hypotenuse, that's sine, so sine theta. So what we're going to do is we're going to say sine of 23.75 degrees is equal to opposite, let's call that h, over 4.9941, and that's in miles. So multiplying both sides by 4.9941, we're going to get 4.9941 sine 23.75 degrees, and that is equal to h. Again, we can just type this directly into the calculator. And again, make sure we are in degree mode, and we end up with 2.011357 miles. So what we need to do is, well, we have this height in miles. The problem is we need to add that to this height measured in feet. So we have about 2.0, let's call it 1 miles, plus 8,720 feet. So what we can do is we can either turn this measurement in miles into feet, or we can turn this measurement in feet into miles. Doesn't matter which way we go here. I'll go ahead and turn the miles into feet. 2.01 miles, and there are 5,280 feet in 1 mile. We end up with 10,612.8 feet. So what we need to do is add the 8,720 plus the 10,612, and running out of room, but if we add those together, we end up with about 19,332.8 feet. And that's the height of Mount Kilimanjaro.